Well, hello everyone, and welcome back to Adrian's Digital Basement 2. On today's video, I'm going to be trying to revive and clean up and lubricate this Apple or Sony 400K floppy drive. This comes from the Apple Lisa, and it's really gummed up. I think if I try to put a disk in there, this thing would just be locked up solid. I have done plenty of services in the past on 800K and 1.4 meg floppy drives, the Sony variety, like this one. This is the one I've been testing on the Lisa, and it does work actually. You can see the biggest difference here is there's quite a height difference between these two drives. Now, actually, I could use this one in the Lisa because I went into my parts bin and I found these little standoffs that I could put underneath. And with those under there, these should be actually the same height. My face is causing it to be out of focus, but the slot would be at the same spot. So this one should work, and electrically it does work in the Lisa, as I showed in the last video, which was part 6 on the main channel. When this video comes out, I'm not sure which Lisa part will be the most recent video. So really, I'd like to try to see if I can revive this drive versus using the 800K drive. And actually, this is kind of funny, and I'm kind of ashamed to admit this, but I actually have another one of these, and it's in box. I think it's not new in box necessarily, but I think it was a drive that was taken out of a Mac 512 or 128 when the user upgraded to 800K. That was a common upgrade for Mac 512s, was to change out the ROMs to make it the KE, the enhanced version, and then you would install an 800K disk drive as well. And people often took these full height drives out of those machines and replace them with probably something like this that had some spacers underneath it so it would mount in the case. And unfortunately, I know I have that drive and it's in an Apple service box even. I can't find it anywhere. I spent a few hours looking for it today, and it's just one of the issues. I'm really out of space down here in the basement, which is why I've talked about the fact that I really need to fix things and then move them on to the local community. It's possible actually that I did that with the 400K disk drive, thinking that I would never actually need one, but I don't think so. I remember it was around here in the original box, and I looked at it thinking, wow, this is a big floppy drive, and I thought, oh yeah, 400K drive. This was before I got the Lisa, and now I'm not sure where it is. It's possible it's at my storage unit, and unfortunately, I keep an inventory of everything that's there, which is fortunate, but I looked at the inventory, and I don't see that disk drive on there. So I don't know where it is. So that means I'm going to try to get this drive cleaned up so it could potentially work again. And this is my backup plan, this 800K disk drive. Okay, first things first, I have some junk floppy disks here. These are bad. I just want to see if this drive even attempts to suck the disk in. Okay, it does not. So this little plastic piece that's moving, that should release the mechanism and it should pull the disk in, but that's not doing anything at all. So very common problem. You can see how dirty this drive is. They just get really gummed up. Sony model OAD34V, pretty sure that this is the exact same drive used in all the other Macintoshes as well, like the 128 and the 512, the same exact model. Although don't quote me on that because I haven't actually looked at one of those. Because when I've worked on those Macintoshes, I don't remember ever actually taking the disk drive out. The disk drives always just kind of worked. These are more reliable than the later ones because the eject mechanism is metal and it doesn't have a plastic gear like in these. This is a little gearbox with a few gears in there that does the eject mechanism. These always strip out, but I don't think that's the problem on these. Anyhow, these were the little spacers that are used to mount it in the Lisa chassis. If we flip this over, December 1983. So that's kind of cool. That's actually from before the Macintosh came out. I think the very first Mac was sold to the public, in the very beginning of 1984, if I recall. Now, unlike the rest of the Lisa, this drive didn't really get exposed to battery corrosion. It's just really gummed up, and I think the machine was owned originally by a smoker. So it has a cigarette smoke smell to it, and I should probably put on some gloves. This is kind of curious. It's a little bent metal piece, but I wonder if that's normal. Okay, that probably is normal. Looks like pushing the disc in kind of moves it off to the side. And I wonder if that just adds a little bit of resistance to the floppy disk so it doesn't just slide in and out really easily. There's a little bit of drag on that. Now, taking this apart will be new for me. We have a bunch of circlips, so that's going to be interesting to make sure that I get these off in a way that I don't fling them across the room, because then I will never ever find them again. Circlip there, a couple more circlips there, more there. Okay, well, I'm not really looking forward to this. I was actually really hoping to just get away with using the new old stock drive, which wasn't dirty like this. But anyhow, here we are. Worst case, I have the 800K drive, so the Lisa will be with a disk drive no matter what when it gets reassembled. But yeah, there we go. All right, well, let's start with this top cover. And there is a fastener, although it's an interesting fastener. It's got like a center hole, and otherwise it looks like a flathead. I thought I saw a second one of those around. Look at my fingers getting all dirty already. Ugh, gross. Okay, yeah, it looks like that back fastener comes out. At least you can get this top cover off. And every part of this drive needs a very thorough wash. Okay. So what I'm going to do, because I'm going to misplace screws, it's not like I have another one of these. I have so many of the other disk drives, but not this one. I'll put this fastener back in if I can, just so I can remember where things go. All right, top cover removed. Let's take a look at this insertion process again. Yeah, my assumption is when this little thing flips, which luckily it's not broken or anything, the drive should go down. The entire top sled part should click down with the disc. Now there's the read-write head. There's the little pressure pad. So we can definitely see that this is a single-sided drive. I'd say that this little lever, this is for opening the shutter. That's my guess, at least. And it's supposed to spring back and move freely. It does not. So that should be over here. And there we go, it opens the shutter. So this is gummed up. And then when the disc goes in and the shutter is opened, pretty sure that this whole bar on the side should go that way. And it can move freely, can slide on this. This is the eject motor. But I think this grease in here is just super gummy. So, okay, so I think when you push this, that part pushes on this little lever here, and this should rotate up like that. So I'm just trying to free this up so I can kind of see how this is supposed to work. There we go. Okay, so that's in the down position. No disc is in there, and when you push this, it goes up and allows you to get the disc out manually. Let's see if this is starting to work. Oh yeah, it's starting to work. Okay, there we go. I think it's in the down position. I can't turn the spindle by hand, but we can see that the pressure pad is pushing on the top of the disc. So the biggest issue is all this grease that you can see is turned hard. So I really need to take this thing fully apart, and definitely a bunch of these circlips are going to have to come out. That's not exciting, not at all. So I'm just going to use a pick here. There's one. Okay, so that's a good tactic. You just use this and make sure you have your hand over it so it doesn't go flying away. I think these are different sized. Let's take this one off. Now, of course, there's a special tool for this. Okay, that one came off. There it is. Okay, this rod, I assume, slides out now that I have the circlips off, but it completely doesn't move. Oh no, it doesn't. Does that slide out? Actually, it looks like there's some kind of a spacer there. Keeps that from sliding out. I don't know if that's just sort of something that's floating. I might need to put some lubricant on this just to help it move a little bit. Let's find some lubricant. Let's see here. I've got a whole bunch. This is like some bearing oil. I don't think that rod is supposed to slide anywhere. I think that allows you to, once this is all off, we could get the side off maybe? I'm just not sure. Okay, next thing I'm going to do is disconnect this eject mechanism. This may be a giant failure. That's sort of the silvery colored one versus the gold ones, which were on the rod. What I am going to do to help organize, so we're going to use this little box. Let's put these in here. That way I don't accidentally bump them and have them fly off the table, and then that will be the end of this disk drive. Okay, so just trying to figure out how this works again. Okay, so if this goes like that, and you push this lever, then the drive goes down. The other drive, the 800Ks, are so much easier to take apart. Looks like it's all on this side. So on the other Macintosh, on the older, or the newer drives, I'm sorry, it goes over to the other side, but it looks like this whole sliding bar with these springs, I think this is it. So I'm pretty sure I have to get these off, and then that should really start getting this thing to come apart. I gotta say, this mechanical stuff is definitely not my forte, that's for sure. It's really not what I'm good at. Okay, I got it. There's one of them. Yeah, that's so gummed up, so gummed up. This one here. Think I got it? Okay. Tiny, tiny little things. These come off now, these washers or something. I don't know, I feel like that's a washer, but it doesn't budge. Yeah, I mean, this has to come off, right? There'd be no way for this to come apart otherwise, because I got to get this sliding part off, you know, by unhooking this spring right here. Let's do that. Okay, like that. So there's that spring. I'm going to put that in with the circlips. I think this one's okay, because I think this is attached to this little point. That should come off. That should come off with this whole bar. And then this part, I can flip it like that. Once I get these off, this part should come off, I think at least. Okay, so this turns. So that's something. This one. Oh, that's stuck. Wow. How about if I put some IPA on there? Just a little bit. Okay, that's freed it up. Oh yeah. Oh yeah. Okay, cool. Let's try to get that out from the backside. There we go. Ha, it was stuck. So obviously I really need to clean those really well. I'm gonna put a little IPA there on that one. Wow, that thing is just rock solid. Doesn't even move at all, no budging. I wonder if I should like apply some heat. I'm gonna put some heat on it just to melt that thick, sticky, yucky grease. Okay, it wasn't too much, just a little bit. Did nothing. Nothing. Unbelievable. So that's some of the lubricant. Okay, look at that, I've got it to budge. A tiny bit. Oh yeah, there we go. I think that lubricant helped a lot. There we go. So there's that little piece. Put that in with the other circlips. And now, there it is. Look, it's off. Hooray! Gross. And now I can get to this a little bit better. Yeah, this just kind of goes up and down. So it just pivots. And it pivots on this thing I took the circlip off of. So I don't know why there was a circlip. Oh, you can push this out now. Ah, okay, let me try this. Aha. So let's see, does this all come out? Yeah, this comes out. Okay, so this was on with those two circlips. Something fell. Okay, this was a little spacer that's on the rod itself. So I'll put that on there, like that. And there should be another one right there. Let me grab it before it falls out. There it is. We'll put this on the rod. Okay, there we go. So this is kind of free. Okay, I think I need to take out this little pressure pad thing. I'm going to put that with its screw together in there. Okay, based on the fact that there's like a notch there, I have a feeling this is supposed to come out on the other side over here somehow. It's like we're nearly there getting this top piece off. Then I can really clean this properly outside of the disk drive. So I feel like it can't come out on this side because there's a thing there that's notched in, plus there's these hooks on the top. It's got to come out on this side first, so like this towards me, and then I can slide the whole thing out. But it's catching on this plastic piece here, which is this piece. Oh, you know what? Look. That screw and that screw, that should release that side plate. I think that's what we have to do. Okay. Yeah, look at this. That's all I needed to do. Okay, what's it getting hung up on now? There it is. This is interesting. This is the disk insertion sensor, so it breaks that beam. So that moves up and down. Write protect tab, same thing. So I need to clean those up. Oh, this drive is dirty. It is dirty. And there's the head assembly. So that moves. That's good. The motor's not frozen. That motor's not frozen. I think this, let's see about the eject. This is geared, so I can't just turn that. There's a gearbox right there. Okay, well, yep, so lots of cleaning and lubrication needs to happen on this. We have to be careful these nylon parts since they are fragile, but they do work. They move okay. So that's definitely integral to the design of this thing. And then this piece, this needs to be, I mean, this is supposed to just move freely, and this is super gummed up. So that needs to be cleaned up. And this piece, this is just gross. That needs to be cleaned up. And as for what's on the drive here, obviously don't want to submerge this with water or anything like that. But yeah, if I see anything that's like greased up and needs lubricant or need to clean the grease off, let's see, is there grease on this? No, that's dry. I might just clean this with a brush. Hope for the best. But this stuff, on the other hand, I'm going to take this upstairs and I'm going to submerge this with some soapy water, warm water, to try to get all the grease off and a brush. And yeah, I'll be back. All right, the Sonic cleaner is running upstairs that has those top parts in it. I was trying to get all the grease off just with a brush. It was not effective at all. The grease is so caked on and hard. Yeah, even hot water, nothing was really getting it off. Okay, well, there's obviously electrolytic caps. We have 5 that I can see, or no, more than that, okay. There are 7 that I can see on this board. And this board is not the same as this board. So, geez, oh boy. Also seems like maybe there's a crack in the board. I thought this was a hair. Oh no, maybe that is just something that's sitting on top of it. Anyhow, getting this board out is not easy. I wonder, because it's kind of underneath the spindle motor. Well, I guess I should try. Early 400K Sony drives are absolutely notorious for having issues with caps. So I wonder how this comes out. Obviously, that's just a shielding for the IC that's under there. I guess I'm going to have to take these off as well. Oh, this drive is a pain in the butt. Absolute pain in the butt. What I probably should have done is test this drive just to see if it's working or not. That way I can avoid all this disassembly. Okay, so this is loose with those 2 fasteners out. I think the motor and the PCB They're all attached. These circlips obviously have to come out, at least these two. There's a track 0 one there as well. Well, it's not a circlip, it's just a sensor. So let's see if I can get these out without flinging them across the room and or breaking them. Okay, there's one out. Put these with that stuff. Okay, second one is out with this sensor. So this is like a bodge? This cap? Give me a break. Yeah, it's some kind of a bodge. See, there's a... this wire goes under here. Come on. Uh-oh. Just that spring. I'm glad I didn't lose it. Need to keep these together. I'm wondering if there's a video on the internet already about this service. I should probably go look for that. Oh, I just realized probably should have had this inside the cleaner as well. Yeah, that's fine. Okay, so the board does seem to be moving. So I really have to just try to get these connectors off, if these are connectors. Gosh, I'm not even sure. I wonder if it's easier actually to take this bottom board off and then unplug those connectors. That is probably the case. The sonic cleaner just finished upstairs. I'm going to go check on it. Had it in for 10 minutes. Okay, another 10 minutes are required upstairs. So let's resume. Yeah, this drive is a pain in the butt. Okay, so those 3 fasteners are out. Let's get these cables unplugged. So yeah, the reason why I'm doing all this is because this board is the speed control board plus sensors and stuff. So if these caps are having issues, the drive's never going to run at the right speed. I have a feeling this bottom board doesn't have any electrolytic caps on it. Now I have to try to find, oh, it does have a bunch of electrolytics on it as well. Great. Well, Sony has enough length on the cables at least, so that's nice. And now that I see this, the spindle actually goes through a bearing right here. Okay, so well, the cable's unplugged. So these wires on the top can feed through. But the question is how does this come up? If it can at all. So see how that moves? This shaft here, when we push on it. Bunch of electrolytics on there. At least they haven't obviously leaked. But it's nice that there's enough length on the cables to kind of tilt this down. Thank you for that, Sony. So there's some serviceability here. The question is what about this? What about this bearing? Oh, and there's some screws there. What are those? Oh, that screws into this. Okay. I don't think that needs to come out. Not to get this PCB out. How does this come out? Also notice that this is a heatsink compound, or it's for heat sinking that chip, because there's actually heatsink compound on there. I see what's happening. It's hitting that. So I've got to take that off too. This design is not serviceable. Even though there is extra length to those wires, I have to loosen this. This is what holds down the slider, which I really didn't want to take off. But there it is. I think that's why it wasn't coming out. Yep, that was it. That was specifically it. There it is. It is free. There it is. Okay. Okay, so there's that board with this little heatsink thing, which actually is, I thought it was soldered on. It's not. So I'm just going to slide that back onto the front here just to kind of hold that in place. And I think I'm going to put this back just so I remember that's where it goes. All right. So that means those electrolytics are accessible now. Sorry, it's a bit blurry. Is that a cap? This silver package? Interesting. Anyhow, so those are accessible. And these are accessible. Let's make sure all of them are accessible. How about that one? Yep, it's right there. Those. I mean, the good thing here is usually when there's corrosion, it's visible. You can see it, and I don't see any corrosion on here. So that's good. That's very good. Now what I might do is take these off, and I'm just going to install caps on the other side. Surface mount caps. So what I need to do next is I just need to make a map of these caps, these 5, and the 7 that are on here, just the values and the polarity and stuff like that. I could do it with pictures, but also it's helpful just to write it down on a piece of paper. And then I need to try to find appropriate substitutes. Well, a bunch of time has passed, and I've gone ahead and I recapped these boards. This is the map for the motor speed controller board. So 10 microfarad, 16 volts, those ones, that one, and that cap. And then we have 0.47, 50 volts there, and 50 volts, 1 microfarad on that one. And the bodge, which isn't actually just hooked up to the third wire, there's I think a diode there. It's under heat shrink, so I can't tell exactly what it is. 0.22 at 50 volts. So what I've gone ahead and done is kind of ugly, but it's going to work. I just don't have any of the really tiny caps that, I mean, were originally on this board. It's so wild to think like these caps have the same values as these large ones. Either way, I have them lying down, the 3 that are on the top, the rest are on the bottom side, which I'll show you again in a second. So there's the bodged on cap with that diode or whatever that is. Here's the 0.47, and as long as it's not taller than where the disc is, it's fine. And this one up here, 1 microfarad, 50 volts. So yeah, they're all lower down, so it should be fine. And then on the bottom side of the board, tantalums. And there's a bit of flux residue and stuff, but I think it should work. I've double checked to make sure nothing is shorted, and nothing is shorted. And it really doesn't stick down very far, so I think there shouldn't be any issues with clearance. I mean, there might be. And I'll figure that out shortly. There's a bodge wire here because unfortunately there was just too tight of a space right there, so I installed a bodge wire. And yeah, I think that should be good. So this one's backwards, by the way. So tantalums, the line is towards the positive side. And on all of these caps, the negative is facing down at the bottom here, the bottom edge of the board. But this one's flipped around where the positive goes up to that winding there. I think these 3 have to do with the 3-phase motor windings. And then there's that one there. So it's kind of ugly, but luckily you're not going to see that when this is installed. And theoretically, it should work, I hope. If it doesn't, then I'm going to have to order caps. I just don't have any of those that are going to work for this. And then as for this board, this was a little bit easier, slightly. I was able just to put the caps on their side. The originals were pretty small as well. I'm not sure any of these were actually leaking, but this thing was so hard to take apart, I don't want to risk it. Yep, I just do not want to risk it. So these 2 caps are actually relatively small. Oh, let me find the map so you can see what values there are here. So those 2 were relatively small, just not small enough. So 22 microfarad, 16 volts. This one up here, 47 at 16, and I had to get creative and really kind of lie that over with one leg, making the long route. And then these 2, pretty simple, those just lie down as they should. So I guess the question is, will this all go back together? First, let's try the speed control board. Make sure I can actually get this in. Oh, okay, I got to remove that clip again, don't I? Yep. Let's move all this mess out of the way. It's back in. That screw, there's like 2 standoffs. That one is fully seated. That one is fully seated. Unfortunately, I can't really check for clearance because you just can't see it. Oh yeah, okay, I can see in there, and there's plenty of clearance from those tantalums down to the metal structure. You can just sort of see them back there where my fingers are. Okay, we're looking good there. Excellent. And then as for this board, this one should go in as well. I don't predict any issues. There's a lot more clearance available for this board. So there's one standoff. And that's good. It's funny, there's a whole extra connector, by the way, right there that's not actually used. I think what I'll do is I'm just going to loosely fit some of the fasteners on the bottom board at least. I'm just looking to see where I installed the caps on this bottom board. So there, 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 and there. Okay, there's none in this area because I can see there's no clearance there. And the board is kind of bending, but I think it's because of these wires that are just sort of shoved up there. That's the way it was from Sony. And I mean, I can see down there one of the caps I installed. It has tons of clearance. Yeah, I think the bottom board, I think that's looking good. Now this top one, yeah, I think that's good as well. Oh, you know what? Before I put the screws in, where's that heatsink thing? Here it is. This has to go back on. This wasn't actually soldered, or if it was, it broke. And that should be soldered on there. Because that tab is definitely part of the heat sinking for that main IC there. Terrible thing about this whole drive situation is you can't test it until the drive is back together more than this. I suppose actually I probably could test it if I just put on the sensor up and downy things, those little plastic things with the springs. I could test this by just holding the disc in place. We could see if it, you know, spins properly and tries to work. All right, fasteners are all in, but look, but there's no caps over in this whole area. The caps are over here. So this has got to be that wire that's just pressed on that board for so long that it got like that. And now we have the little plastic up and down thingamajiggies. So these have springs that go on here like that. One there. These things go back on the correct way. They only go one way. Okay, and now I got to get the circlips on. So get these very carefully. Oops, I dropped one. Luckily on the bench. I'm deathly afraid of dropping one of these. I don't have more. I could probably steal them from something else. Okay, and they are too hard to get back on with your fingers. Click. One's on. Okay, both of those are on. So let's just double check they work. Yep. I'm going to spend a moment to clean the head since we're here. And it looks real dirty. And before I forget, time to put this little thing back on here, the retaining clip for the little guide bar or whatever it's called. I have no idea. Electrically, I think this probably should work. And I'm thinking this is probably something that I need to test before I assemble this any further. I mean, I have all the mechanical parts here. They've been cleaned. Not relubricated, but cleaned at least. But I'm feeling that I should probably plug this into the computer. And all I need to do to trick it to think a disk is in is just push down these sensors. I think it's the one on the left here. I think this one on the right makes it think there's a disk in there. And we should see it seek and do stuff. I'm going to clean this jack screw thing. I mean, it's real gummed up and not looking good at all. Not even the best way to clean this. I don't think it's that, because that jack screw is real gummy. So what if I use a pick and a piece of cloth? I'm not sure I really need to do too much with this. I mean, I know it's dirty and gross, but that motor is big. It probably can fight against a good amount of stick. Yeah, I mean, just gripping it with my fingers seems to do a pretty good job, actually. Does turn. The motor's turning without issue. That's good. Well, that's probably as good as it's going to get. I don't think without fully disassembling the drive, we could really do much more than this. Track 0 sensor right there looks fine. I'm not going to touch any of the alignment by loosening any of these screws that hold this stuff down, since, say, moving this sensor will completely change the alignment of the drive. And that's not something I want to do because I have no idea how to even calibrate or align this thing. A lot of times these bushings that ride on these slides here don't need any lubricant at all. And I am not going to add any because this moves very, very nicely. And the only thing that, you know, you potentially want to add is a little bit of grease on there. Obviously there was some because I just cleaned it all off. So I should, I guess, add some. I'm just going to use white lithium grease, and I'm just going to put a tiny little bit, basically right there. I'm not going to add more than that because as this turns, it should drag that around. Okay, maybe I'll add a little bit more. And I'll just wipe up the excess. There we go. Okay. I'm going to call that good. Okay, well, the question is, should I try powering this up like this? I'll have to get the whole Lisa out. Or should I try putting this back together some more? Let's see what I got in here, if anything. Okay, these are just for the bottom, so I don't need to worry about that. And then this one, yeah, there's a lot of stuff there. And I'm worried if I leave this till tomorrow, I may not be able to get this back together again. So with that said, these are the parts after they were cleaned. So I'm not lubricated, by the way, but things are moving freely now, which is good. And this one here, this also moves freely. You can see there's still residue on here. It just, I mean, this thing was in the sonic cleaner for so long, and there's still residue. But you know what? I made sure that everything moves freely, and it does. And same on this one. There's just this little thing here. There we go. Focus. There we go. That moves freely now. And all this stuff moves freely as well. Right. So how do I get this all back together? That is the question, everyone. That is the freaking question. So this has this little lever. I don't really remember taking a screw out over on this side, even though it's got a threaded hole. I may need to review my footage because I don't know. I almost feel like it's going to be better if I actually take that side bracket off. I didn't to take it out, but I think I should have. Or maybe actually just loosen the fasteners to make it wobble. It'll allow it to wobble. Yeah, like that. Oh, these stupid caps. I need to get rid of this. I need to clean up the bench. It's a disaster. Right, because I think this little thing needs to go into here like that. Okay, like this, I think. Oh yeah, and then this, oh shoot. Okay, this has to go up here. That has to go under. That goes there. Okay. I think there was, oh, right. This thing, this little metal thing, that did screw into the side here. Right there. Okay. This fastener holds that in place with that little arm thing. Right. Okay, like that. Okay, good. Now all this grease was on this side, and that's where I have to think about this, how it goes back together. Now, I guess the question is, should I use oil or should I use grease? I think, you know, they were using grease, something like this. So I guess I'm going to do the same. And I'm going to be sparing. All right, so there we go. That's smeared around there pretty well. So I think the part that's was gummed up was this piece. That gets lubricated last, or gets added last. So many missing pieces here. Okay, I think I'm going to just loosely install these fasteners as well. That's in. Now it's all wobbly because everything is loose. Because there's obviously stuff that has to be installed. All right, so this is the tricky piece, because this shaft has these little spacers on it that I have to get into place with my tweezers. So let's grab one of these. Please don't go flying away. Okay, that one is in. This all moves so much easier now that it's not all gummed up. There we go. Okay, that shaft is in. It takes a circlip on both sides. Okay, where are we here with this whole mech? Okay, so this piece has to do with the side piece. All right, I definitely forgot those. I remember them being incredibly hard to get off. I think they were on this. I know this goes towards the front because that's the eject thing. I'm just gonna try to figure out how this works, roughly. Okay, I see. All right, so those actually go on these little pegs. So there's a peg there and a peg there. That's what those go on, and that's this. It rides in there. I'm just going to try to figure out how this works. This is supposed to go under that, but how? How did I get that off? You know what's so funny is I think I made my life much harder. I think this would have come off a lot easier if I just unscrewed all those fasteners with the 4 and the whole mech would have come off. Because with that off, I could slide this in under there. Okay, I'm going to try that. This is mostly together. Mechanical freaking puzzle. So you have to be careful because this has to come off here. There we go. Okay. Let's see here. That probably was the right way to do it from the very beginning. Not the way I did it. Again, I'm not trying to put this on all the way because I know I have to lubricate this. Just trying to figure out how to get it on so that when it is time and it's lubricated, I can figure out how to get this into the right position. Okay, I'm really struggling here. This is a freaking puzzle. I think what I need to do is clean these little bearing things that were so absolutely stuck. I didn't put those in the cleaner. I need one of those loose leaf tea things so I can put small parts like this into the sonic cleaner. And I don't have one because I don't really drink tea, and if I do, I use a tea bag. So we turn this back onto its side. These go here. And that's what this whole thing slides on. All right, so from my understanding, we have to flip this up like that. Oh, this must go the other way. Like that. Okay, so we got to flip this up. Okay, I think I pretty much have this. So you lift that. So I just need to put a little bit of grease. I'm going to be very sparing with the grease. Again, I'm going to use just the tip of this. Put a little bit on these bearings here. And I'm going to put a little bit on here. I can add that after, actually. And I'm just going to smear a little bit under here. So this has got to flip there, so this can go up. Of course, this little spacer came out. I should have put those circlips on this bar before. That's okay. I should be able to slide this out because I want to get this circlip in. Kind of holds this thing together. Crap. Okay, so that came off where it's supposed to be now. And all my fiddling around, I can get that back on. Because these have circlips that need to go on as well, which I haven't put on. These super tiny ones. Okay, that one's on. Okay. Oh, okay. What's next? All that's really missing at this point, I think, is to screw this all down. And then there's a circlip there for the eject mechanism, and there's a spring that goes there. So the key is, oh shoot, I just let this come out. I think the key is for this drive is I should have removed the whole mechanism before trying to take it apart in place, because it's actually kind of designed to come off as a whole piece. So now I'm going to try to put the screws back in, and we'll just see if it's operating correctly or not. This is fascinating content. Oh wait, no, it's not. At least I know the trick now. It's to take off the 4 screws on the bottom of the eject mechanism, and you can get that off as a whole unit. That's that's way better than the way I did it. Okay. So this is all kind of loose right now. I don't have the fasteners tightened. Looks like it's in... Okay, let's see what's happening here. Okay, this piece is not in place. There we go. Okay, something is very wrong here. So what's wrong is I think there's nothing holding this on. That's the problem. And I think I have these little bushings on backwards. They're flipped around. I gotta take this all apart again. You're kidding me. Yep, I do. Oh, man. Struggle bus in the house right here, everyone. I knew that stupid slidey eject thing was going to be my undoing, and absolutely it is. I got to take this thing all apart again. Yeah. This is so fun. So fun. Okay, so at least that comes off. So I can work on this separately. All right, so I got to take these stupid circlips off and this spring off again. That was easy. Just let that hang for a second. Right. Okay. So I got to get this off by moving that down. Then that comes off. Now I got to take these clips off again, circlips that is, and flip these stupid bearings around. Great. I got to do this in a way that's not going to be destructive, and I'm not going to lose these tiny circlips. Because if I did, oh good, there we go, one came off. So I'll put that in there. Okay, so I see how this works. I need to attach that slidey piece, then put these bearings in, then put the circlip on. Okay, there's the other one. They're both off. And now the bearing. This is what I couldn't get off because the grease had frozen it in place. At least now it moves. So like that. Okay. And then this, let's get the spring off. Okay, there it is. So this now goes on here. Got to get this stupid flip up mechanism out of the way. Okay, like that, essentially. And now this goes on like that, and like this. And now I have to get these circlips back on. What a ridiculous situation this is. Don't even know if you can see what I'm doing. I think you just can. Make sure those are pushed down all the way so the circlip can go on like that. Guess the grease helps because it keeps the circlip in position. Okay, that one's on. There we go. There we go. Theoretically, once I put that spring on, we can actually test the mechanism to make sure it goes up and down and it's moving smoothly. Okay, so those 4 fasteners are in. You can kind of ignore what's happening here. Just pop that on there temporarily. Oh, yeah, I got to put the screw on, or spring on. That's the last piece. And when I say last piece, I mean to the puzzle. Okay, that's just sitting on there. Is this thing going to work? Okay, eject sound feels normal. Okay, this is in the wrong position. Okay, something is still slightly unhappy here. Yeah, I'm not sure what's going on here. I don't think this is going to work. Oh, kind of did. Wow. Okay, let's add some lubrication to a couple points. I'm going to put some up here. We'll add some more here because this is obviously a sliding point. Both of these. So I push this, it ejects. So the weird thing is it goes down, but not very well. I don't really know if that's the way it's supposed to. No. Okay, so it's working. It just needs a bit more lubrication, I think. Okay, so what's weird is I'm used to the other Macintosh drives, these ones. So watch these ones. If you put the disc in, oh, there's already a disc in there. If we put a disc in, it basically snaps it in like that. I barely had to push it. But this drive, on the other hand, is not working that way. If I go and push it, notice it's not going down. You kind of have to give it a push, and then the drive snaps it down. And you can tell you're in all the way because this bar, as it goes forward, that's what it does when you push, when it goes down, and it's going all the way. It doesn't go any more than that. So the disc is getting pulled in all the way, but it's just a lot more clicky and a lot less just sort of snappy and pulls it in with no force. Watch. See, I didn't have to push the drive at all. But this one, I think if I'm not holding the drive, see, I'm just pushing the drive. It didn't go in at all. You have to hold the drive and then it goes down. Is that normal? I don't know. Okay, I think I see the problem. This is on the wrong side, and I don't want to break it, but I have to move it. Okay, there we go. Let's try that now. Oh, it's in the eject position. Okay, well, that's better. This white piece somehow was underneath this kind of lever there. Let me show you a little closer. This part was under that, and it needs to be on top. Because when you go to eject, it lifts it up. See how it lifted up there? And that gets that kind of pushes the disc out. The mechanism just feels more stiff than the other drive, but this moves normally. So I'm assuming this is going to work. And the last part is just to hook that up, maybe put a little grease on it. This is the eject mechanism, and there's a final circlip that goes on there, like that. So that's now connected. I mean, that won't affect what we were just testing, because if we eject the disc manually, Still the same. I think what happens when the motor turns, there's an eccentric here, and that pushes this, well, it kind of catches that bearing right there, and it pushes that whole lever and this whole mechanism that way. And that's how the disc gets ejected. The force required to eject the disc doesn't seem unreasonable, so this should have no problem actually ejecting it. And like I said, the only thing is you have to push it with more force than the other one. See, I still have to hold the drive, but it clicks into place quite nicely. And I suppose if you are going to service one of these, what you need to do is disconnect this, take that circlip off so the eject thing is off, and then you can take the 4 screws out and get the whole eject mechanism off without all that rigmarole I did at the beginning of this video. The only point I can see that actually lifts the drive is right there, and this stabilizer bar is actually what pulls the whole mechanism up as a whole. So this is it. The Macintosh drives, these actually have something like that on both sides, and this slidey part actually goes underneath and has a second side, probably to make the whole thing smoother, but I think this is probably how this drive just is. And I guess the final step is, and well, there is a cover that I could reinstall with that screw that I left there. I might as well, let's put it on. That only takes a split second to get off. And then this drive needs testing. It needs testing. That's it. I'm gonna clean up. We're gonna test. All right, I have Lisa back on the bench, and we're gonna first test with the known working disk drive, the 800K disk drive, before we try the one I just serviced. I wanna make sure the Lisa actually boots first, just in case I don't wanna go chasing my tail due to some other issue. Basically, it should start to boot off the floppy disk that's in here. This is a good 400K floppy drive of LOS disk 1. Oh, keyboard not connected. Fine. I didn't realize I had to have that connected for the diagnostics to pass. Oh, I just noticed it actually went past that, which is fine. I don't need to actually push anything. We'll start to boot. And let's see if this gets into the LOS error screen. It's going to say, you know, no hard drive found. And that's, of course, just where I left off last time I was testing the Lisa on the main channel. So an interesting thing, by the way, I was reading in the Inside Macintosh volume, or Inside Macintosh book, it's a thick book that Apple published around the time the Mac came out, and it mentioned that the 800K floppy drive, which we're using here, ignores the PWM signal used for variable speed control. It's actually generated on the drive itself. And the 400K drive does need that signal, which is what this board did originally. This light adapter on the Lisa has a clock or a crystal oscillator and a bunch of logic chips, and it generates this PWM signal based on the track, because Apple 3.5-inch drives actually spin at different speeds depending on where the head is on the disk. On the Lisa 210, which is the board that's in here, this is kind of erroneous or irrelevant information if you're just looking at the rebuilding this drive video, but for the Lisa, it generates that signal on board now. But the older Lisa 2.5 logic board and the original Lisa 1 did not, which is why this adapter is needed. Okay, this is normal. So this booted up without issue, and we hit cancel, and this will eject this drive. Now the eject gear on here is in bad shape, makes a horrible sound, but this does eject, and that's because I'm using this cable with the yellow wire with the 800K drive. Yeah, this takes a while for some reason. They call it released when it's talking about ejection, by the way. Ejection. There it is, sounded bad, but the disk came out. Cool. So what this is gonna do is reboot the computer, which will just turn off the power. And let's swap over to the 400K drive, and let's hope that Magic Smoke's not released, because that's what I'm kind of afraid of. So this drive needs to connect up to the light adapter, because this does need the PWM signal, although there are the bodges I have that just bypass this adapter for the most part, and the PWM signal is coming from the Lisa itself. So there it is, drive is connected. Let's move this out of the way so you can get a clear view of the drive. When I power it up, I can take this disk out. So the question is the Magic Smoke gonna come out of this drive when I power it up, or will it work? Fingers crossed. It will not let the Magic Smoke out. Of course, if it does, I have a working 800K drive I can totally use in the machine. But here we go. I'm going to turn on the power supply. Power's not on yet until I push the power button, which is this right here. Here we go. Okay, so the head moved back into the track 0 position. That's great. No magic smoke came out of the drive. And it is passing its diagnostics, but that's normal. It doesn't really do anything else. Okay, I'm going to put the disc in, the working disc. Oh, you know, maybe I should start with this crappy Microsoft disc. No, I don't want to, because the problem with this disc is it sheds. That's why I don't use them. So if it spins, it sheds. Here we go. Okay, I don't think it's working, everyone. I don't think it's working. It's not spinning. Darn it. Well, the eject works, so that's something. But it is absolutely not spinning. Kind of what I was afraid of, unfortunately. So I saw the head moving. Let's put that back in again. Yeah. Let's see, continue. So the head's moving. Eject works, but the spindle motor's not going. And those were all those little surface mount caps that I installed on the bottom. Ah, darn. Well, okay, I'm going to try something. I'm going to push down the little thing that detects the disk installed. I want to see if the spindle turns when there's no disk in the drive at all. Nope, I don't think it's spinning. So I'm going to hit the continue button. Nope. Okay, well, that was a big failure, everyone. That was a big failure. I think what I might do is take off the shield and take off the mechanism and just see if the spindle motor tries to spin, or if I give it a little helping hand, it can spin. Darn it. This is sort of like a worst case scenario. Power's off to the system, by the way, entirely. Okay, so I have my little box of parts. Put the circlip in there. I think I only need to remove that one circlip, because we just got to take the eject mechanism off, and then I'll take out those 4 screws. I'd be done with this drive. I really, really thought that I'd be done with it. And I didn't test it beforehand, so I just don't really know if there's some other problem with this. I know it's not the computer, obviously, since the other drive works without issue, which is, I'm glad I have the other drive, so I'm ruling out the adapter, cable, stuff like that. Although I didn't use the same cable. I was using the cable that came with this drive, but I don't see how it could be that. This has got to be a problem with the drive or some logic on this board, because obviously this bottom PCB is what interfaces to the computer. It instructs the spindle motor speed controller thing to actually spin the main spindle motor. Just hold this down so it doesn't all fly off. Oh, and I got to take this shield off. So again, what I'm going to try to do is I'm going to plug this back into the computer, power it up. Then I'm going to, with this mechanism removed, so I'll just lift this up. I want to see if when the computer tries to turn the spindle, that the motor is not turning, but maybe if I give it a helping hand, it does. And that just sort of implies that we have a capacitor issue. Let me feel around here if anything is hot. Nope. Nothing is hot at all. And I did reconnect it to the board, right? Yeah, I mean, it is plugged in down there. I can see it. And it's fully seated on there. It's hard to see, but that connector is on there all the way. All right, there is the drive. Let's power the Lisa back on. Power supply is good, just making sure everything is clear. Okay, here we go. Okay, Lisa, as you can see, is powering up. Now, if I push down this sensor, that's going to tell the drive that there's something in the drive. Oh, look. Yes, okay. That implies we have a capacitor issue. Darn it. So see how it kind of wobbles? Wait, now it's working? Really? No way. I assume it's not going to work if I try. Look, there we go, got stuck. I'm holding this down so it thinks a disk is inserted. If I push this, I mean, it's spinning now. This is super indicative of a problem with the caps on this board right here. Oh, I thought I did it correctly, but I obviously didn't. So there's not spinning, but if I give it a helping hand, it works. Yeah, it stops really too easily. I think it's missing one of the phases, or one of those caps I installed, those 3 little surface mount caps on this part of the board. Those are those clusters. I don't have one of those connected properly. Something like that is the matter. Okay, well, I'm going to stop the recording, and I am going to take this drive apart one more time, and I'm going to try to figure out what's going on underneath this board. It's got to be what I did on the bottom side. I just didn't do a good enough job. And see if I can correct this. At least I know how to kind of test the drive as well. Literally just plugging into the computer while it's on and pushing this down. See, it tries to spin the motor there. So, okay. I'm going to see if I can fix this. Okay, well, this was a lot easier to get off, by the way. I didn't even remove the bottom board. I did have to take the circlips off for the 2 sensors. Anyhow, I found the issue. This cap here that I bodged on, look, it's not connected. So the positive side is connected to that lead along, this one goes to there, this one goes to there, but the negative side is not connected properly. So that's just floating, and without capacitance, that whole winding, because this is a 3-phase motor, that's not going to work correctly. It's kind of interesting that it's not connected actually, because it really seems like it should be. You know what might be wrong is these traces are extremely thin on the bottom of this, and I think it's just not connected anymore. So I'm gonna grind away a new spot. Okay. All right, there we go. So this needs to be connected. Okay, these need to be all connected together. And they are. And they should not be connected to the positive sides. And they are not. Cool. All right, that should do the fix, or that should be the fix. I'm pretty sure. Nice. What's annoying here is if I just tested this before I put this all back together, I would have figured this out, because the issue is really easy to see. As soon as the spindle tries to spin, it wouldn't spin. Ah, okay, we have a clearance issue now. So I gotta fix this again. Yep. So that cap is hitting right there. To be honest, that might have been the problem the whole time. Might have knocked it off when I screwed it together. Now I think about it. Okay, I just turned that. Maybe now. Yeah, I think there's enough clearance now. This thing can rotate further than it could before. All right, for testing, I just have those 2 screws in. I just have this sensor sitting there without the spring, so it actually blocks the beam, so it's going to think that the disc is in. Essentially, when I power this up, I'm going to expect the spindle motor to spin normally without any of that issue where it was sort of wobbling. And then I should be able to stop it, and when I let go, it should restart again. All right. All right. I'm going to take the sensor off so it doesn't think a disc is in. So that's just free spinning. And here we go. Oh no, it's still doing it. Really? Look at that. Same exact issue. Okay, so this phase or whatever this is here originally went to there, which went to this hole. That's where the cap was, but I accidentally broke that. So now it goes to there, to the positive side. This one here goes to that cap, positive side, and this one goes to there, positive. Negative side. These are all connected. Just checking these adjacent pins for shorts. No shorts. Yeah, everything looks connected correctly there. I might as well check the other caps that I have here. So this one is hooked up to the minus rail. Yep. And then the positive goes to this pin. Yep. That's another cap I attached, so it's not shorted. It's on the top side, that is. I know there's a couple more caps on the top side. Not shorted. This cap right here. Not shorted, so that looks good. I check this one over here. So I'm pretty sure it goes to there. And this side is on the negative side over here. Yep. Okay, I have my little map, but of course we have to think about this, that it's flipped. So with these three caps, which is the cluster here, the positive was originally all facing the motor, or whatever these three connections are. So that's still hooked up that way. Those two, same thing. Positive faced this part of the board, so that's the stripe there. And then for this one, it looks like I have it backwards, but I don't, because the positive faces the edge of the board. So that's the edge of the board. There's the positive stripe. So that's on correctly. That's a 10 microfarad. These are all 10s, all the tantalums. And then the one microfarad 50 volt cap with the positive facing the inside. That's this one right here. And it's hard to see, but the negative stripe faces the edge of the board. So negative faces the edge of the board. So that's correct. And that is a 50 volt 1 microfarad cap. This one over here is 0.47, 50 volts. And negative faces down. So negative faces the bottom of the board there. So negative faces the bottom. Yeah, that's correct. And then there's just this bodge cap here, which I'm pretty sure is like a 0.22. And the negative faces, the way I drew this, the negative faces the board, and the positive is going to the IC. So IC on pin 3 hooked up to the positive. Yep. And the negative is down here. Let's just double check that that's hooked up correctly. And it is. And make sure it's not shorted. And it's not. And let's see what's going on with this connection there. Is that a diode? Whatever that is, it doesn't register. Well, that doesn't make sense. So there's definitely some kind of a package in there. Is that open? Because yeah, if we do resistance, that doesn't show anything either. Diode doesn't show anything. Oh, it does. Okay. 432K. Let's flip the leads around. 430 kilo ohms. I don't really see how that cap would have an effect on one of the phases, though. This chip might just be, this chip might be bad. TA7259. TA7259, brushless DC motor driver IC. Here are the outputs, and then, yeah, position sensing. Those are those, I'm assuming, the ribbon cables that we saw on there. So pin 3, oh, no, it's not pin 3. Pin 16, there must be two packages. That's the control input. That's where that cap was we were just looking at. That's pin 16. Anyhow, okay, so the second number is for this chip. We are looking for the 3-phase outputs. I suppose what I should do is try to scope the output while it's trying to run. Incidentally, the version we have is the P-type. That the bodge wire is actually connected to pin 12. Oh, okay, yeah, still same thing, this one. That's where that cap is hooked up, the little bodge cap that's on there. All right, well, anyways, so we're looking for the first number, and we're looking for the 3-phase outputs, 6, 7, and 9. So that tells us the outputs are 6, 7, 8, and 9. So the gold markings there. So I just need to scope those while it's trying to run. And maybe what I'll do first is I'll double check that we have continuity between those pins, 6, 7, and 9, and these caps here. I'm pretty sure that is somehow related. Okay, so 6, 7. My assumption is 6 goes over to here, and this is probably a jumper link. It is, which goes to there. So that's connected. Okay, whoops, I was mistaken. So 6 and 7 are right here. So that's 6 to there, which makes its way there with a jumper link. That goes to there. That goes to this cap. So that's working. Here's 7. It's got to go to one of these other caps. It's got to go to one of these other caps. Okay, it's not that one. That's 25 ohms. There we go, 0 ohms. So basically, because the windings of the motor have a low resistance, that's why it shows up as a beep, but it shows 25 ohms on here. It says 0. Okay, and this is the last one here, which we already know goes to there. Okay, so all 3 phases of the motor controller are hooked up to these caps. And I kind of assume that these 3 connections here probably have a ribbon cable that go, yeah, right there, ribbon cable that goes into the motor. So for instance, this one should be on one of these. 0 ohms. That one right there. And this phase should go to there. Nope, this one. Yep. And then that phase. There we go. So everything is connected up correctly as far as I can tell here. I kind of feel like our problem might be the outputs on the speed controller are bad. That sucks. Looks like these tabs are ground, so I can just clip onto that. I don't know. This phase I'm on doesn't look right. See how it's sort of much lower? It should be a nice clear pattern from my understanding. Yeah, that's what it should look like. And this one here? Correct. Okay, so we are not seeing that. I thought it should be a nicer, smoother wave. Maybe that's the PWM signal, though, affecting it. Either way, that waveform, we're getting it on the 2 phases that face the motor, but this third one is definitely not doing that. I think this chip is bad. Yeah, the output driver is no good. I'm curious which phase this bottom one that's not working is connected to, or which capacitor, I mean. Let's pop this off. Oh, I have both fasteners in. I took one off, and I thought I only had the one in. But they're both in. All right. So it's that one here to there, to there, to there. So that phase is not working, which goes to that jumper link, which looks like it goes to this capacitor. Not the one that I had to move and everything. It just goes to one of the ones on the board that are in the correct spot. Yeah, we'll just double check. So it's that phase to there, to there, to there, to that cap. Well, we can check the cap is shorted as well, of course. It is a tantalum, but these are brand new, by the way, from DigiKey. Yeah, nothing, not shorted at all. Yeah, as far as I could tell, everything is hooked up correctly. The issue specifically, I think, is the output on that chip. I think this chip is bad. We could see that it was trying to drive that phase, but it was unsuccessful, and it's not a cracked solder joint. I mean, I could try to reflow it, I suppose, because maybe it is a cracked solder joint. I don't know. Okay, I'm going to turn on the Lisa again. I just have one fastener in this time. I mean, the fact that it spins sometimes is just complete happenstance. But if I try to stop it, it just stops. Yeah, this chip is bad. Unfreaking believable. All that work for a bad freaking chip. Now, not all is lost, because check it out. I have another one of these boards. And this came out of, I think, an HP disk drive. And I mean, it's identical. It's freaking identical. Doesn't have that bodge there. So that's interesting. That could be for the PWM, maybe. But this hasn't been recapped. So I could certainly steal this chip, I suppose, and try it on here. Although, oh, this has some weird wires that run over there. So that's weird. It is different, but same chip. So why don't I swap this chip onto this board, and we'll see if that fixes it. Looking at this board, Sure looks a lot nicer than this one, doesn't it? Maybe I should just swap the whole thing over. Power's off to the whole computer, incidentally. Now, this one hasn't been recapped, but perhaps it works without being recapped. Oops, take that off. Ah, darn it. You can't do it. You can't get this connector off without taking the bottom board off. I'm going to swap the chip over. Okay, there's that chip out of the board. It looks fine. The funny thing is, what's all this kind of green stuff that's on there? I should clean that off. I don't know, it's weird. I don't know if it's corrosion. Something weird. All right. One speed controller chip out of the other one. TA7259. Same exact part number. All right, moment of truth. Make sure everything's recording. It is. Let's turn that on. So, here we go. Oh no! Same issue. Okay, well, there's only one explanation. The motor itself is the problem. Oh boy. Or I suppose it could be those capacitors? Well, the chip sure is hot too. It's not burning hot, but it's quite warm. Oh, come on, really? Okay, well, I don't exactly know what I'm going to do at this point. I really need to cut my losses with this. I have spent so long working on this drive. If I want to use this speed controller, I'm going to have to recap it, I think. I'm pretty sure the drive that I took apart that this came out of didn't work at all. Like, it didn't even try to spin the spindle motor. Or, no, actually, I remember it was the same exact issue where the motor wouldn't spin properly, and that's why I took it apart. And that was years ago, before I kind of knew what I was doing troubleshooting-wise. I wonder if we should just scope the output of this chip. Let's do that, and let's just make sure it's the same phase that's not working, just to kind of figure out for sure what the problem is. Yeah, it looks like the same exact fault. Let's probe one of the other pins that we know are working. Look at that. That looks a lot better, actually, didn't it? Okay, that actually looks the same. And then this one, take the sensor out, put it back in. Yeah, okay, something's very wrong with this one too. Like I said, I recall the speed controller, this one, had the same issue. Now, incidentally, by the way, when I measure the windings of these motors, it's all the same resistance, like 25 ohms. So I don't really see what could be the problem here. I just don't see the problem at all. I'm just kind of thinking about what's going on. All right, well, I think I have to cut my losses here. I'm gonna be asking you, the viewers, anyone who's familiar with these drives and these speed control issues, what do you think is going on here? As I said, those tantalum caps I put on there were brand new, out of the package from DigiKey, still in the little reel and everything, so they weren't reused. The connections are all good, I mean, from what I can tell. Swapping the chip didn't help. It's that one phase that's just acting weird. And to be honest, with this speed control in there, or the new chip I put in there off this board, the motor seems to be running, but kind of even more weirdly. Like I heard it running at higher RPM than it even should. This one never did that. It always sort of ran at the correct speed. So since I can't spend another day fiddling with this drive, at least not right now, I need to get back to working on the Lisa proper. I'm just going to go with the 800K drive, and that's the one that's going to go into the Lisa when I reinstall it. And at some point in the future, if someone has some good tips on what might be wrong here, then I'll try to fix this drive. But yeah, I'm 99.9% sure the exact problem with this one, the one I took the speed controller off of, was very similar to this, where it wouldn't really spin properly, and if I gave it a helping hand, it would spin. So it's quite possible that this failure mode is super common with this Toshiba chip, and maybe in combination with this motor speed control board, and both of these have the same failure. That is quite possible. It seems odd to me that the motor on the Lisa drive has 25 ohms from phase to phase through the motor, and yet, you know, that phase is just not being driven correctly. And the symptom we're seeing where it kind of locks into place, or if you give it a helping hand, it will spin, but it's missing one of the phases. A 3-phase motor running on 2-phase, it will kind of work, but it won't have the torque it needs, and it won't be able to start up a lot of the time. And yeah, that's exactly what was wrong with this one originally. Funny, I did a quick Google for this part number, 7259P. It seems to be used in some kind of turntable, and the failure seems to be what we're having here. Either the speeds are off, and and what's worrisome is because this is used in some popular turntable, I bet you there's a ton of fakes out there on the market. Oh dear, oh dear, oh dear. Yeah, like we look here, I mean, that's so fake. That is such a fake part, I am sure. Doesn't look anything like the ones I have here. I mean, yeah. And interesting is actually on this drive, this was the HP drive, it didn't even have a heatsink at all. At least the Apple one had a heatsink. I'm just suspicious of any of these that come from China. Yeah, these have got to be fake. Before I end this video, I just wanted to point out that I found a thread on 68K MLA talking about the 400K drive and servicing them. And one thing I want to point out here is if you're watching this video, well, first of all, check out this thread. It has some decent information. One of the things I think I made a mistake on is the small motor control PCB. I think the caps used for the phases, which should have been 35 volts. I used 16 volt caps. That was my mistake. Oddly enough, 5, 6, 7, 8. Okay, so this seems more likely. This person says that there are more caps than were actually on my board. And I found this Google Doc drive here that was in that same thread showing disassembly instructions. And sure enough, it said to take the 4 screws out to remove the whole carriage assembly after you remove the circlip for the eject. But one thing for sure is this drive here, this is a OA-D34V-22, clearly different, quite a bit different than the drive I was just working on. The way this whole thing looks is different. It doesn't have obviously those nylon things. It seems a bit more complicated, a little bit different. So there obviously seems to be some variation in these drives. This one's from September 1984. Notice the one I was working on was from 83. In fact, on the bottom side, notice it has this large chip that wasn't on mine either. So yeah, quite substantially different. Yeah, this is all different. So that could explain why things look different here. Now, the funny thing is, by the way, talking about this 10 volt, 35 volts, I swear I looked at those caps and I checked the voltage on all of them and they were all 16 volts. But definitely when we looked at the motor phases, the voltages that were on there were relatively high. I can't exactly remember what they were, but I think that the 16 volt caps I had on there were definitely inadequate. Now, what I was really looking for on this thread was people talking about the fact that the speed controller might have broken on their drive. Here's one person who says that they have some kind of an issue that when they replace the motor controller, their drive starts to work. And actually, look, here's a picture of someone's speed control board. And let's see how different this looks. They have the cover removed from their motor. Their board does not have a bodge cap. It has 8 caps. I don't recall having that capacitor at all, although maybe that one is handling the bodge. Not sure. Those are the phases there, the ones I replaced with tantalums. That thread had a link to this video by JDW. This drive appears to be identical to the one I was working on, or very similar. So the whole mechanism looks the same. Wow, it's so nice to see grease that's not all messed up. And the bottom board looks the same as well. Now in this video, the disk drive was not fully disassembled. It was just essentially taken out and lubricated just on the side because it looked like from a lubrication standpoint, this drive wasn't nearly as gummed up as the Lisa drive. So at least some Macintoshes have this exact drive model. Oh, it says right here, one Mac 128 and Lisa 2, as well as the 512 and Mac XL. Okay, well, not all of them have the exact same mechanism as we saw from that thread. Here's a link to some documentation from Sony themselves on how to do checks and stuff. Of course, this isn't going to be exactly the same, but this will probably have certain info that might be somewhat useful. This looks exactly, by the way, just like the HP drive. I mean, the HP drive was this exact faceplate and everything. At least there's schematics, actually, so I bet you that speed control board should be on here. Yep, this is it. There's the motor coil. 10 microfarads, 16 volts. Those are the 3-phased caps. So I was right that those were 16 volts. They were not 35. It's probably safer to use 35s because, like I said, the limit is being pushed with those. But that is our IC that I suspect has failed. So this 10 microfarad cap is handling the DC voltage for the drive IC, but then those ones are for the phases. Now, incidentally, these are the 3 Hall effect sensors that go into the drive IC that allow it to, I'll just say HOLL, Hole. It says Hall over here, HALL. Anyhow, these are how the drive IC is able to determine if the drive is spinning or not. It's not going to affect the phase output. This is more like an RPM thing. So I'm saying that I still think that this IC has failed. There's a picture of the board, by the way. And yeah, it does have 8 caps. Again, I'm positive the one I was working on did not. I think it only had 7, except for that one connected over here, the bodge. And indeed, here's a picture of the video, and you can see in this location, if there was supposed to be another cap there, it's not installed. There are just 2 holes, and this is before I even took the board out. So that was not me who removed that. Anyhow, back on the thread here, it doesn't really seem like anyone is talking about the fact that their speed controller died. So if I have 2 of these that have bad speed controllers, I think that was just really bad look on my part, because this doesn't seem like a common issue, at least not with these drives. I just noticed here, someone's talking about their internal drive was bad, but they had an external drive that was good. And I might have an external full height 400K drive. I could probably go and steal that out of the internal drive or external drive. Yeah, no one's really talking about the fact that their motor's not spinning properly. Lots of people talking about head height. Lots of people talking about that their RPM is wrong, and they think it's the Hall effect sensor. It could well be the speed controller. I don't know if anyone's ever scoped the output of the speed controller. Good luck finding that part number. Betamax VCRs. Those are them. These are the 3 Hall effect sensors. So this user changed those out. After changing it, the motor spins up wildly and does not slow down, like it's running at max speed with no regulation. Anyhow, well, if I just checked out this thread, it would have saved myself some of the time at the beginning of this video, taking it apart and whatnot. But I had to fully disassemble it to lubricate anyway, so oh well, it's okay. The main issue, of course, is the speed controller doesn't seem to work on either of these drives. I mean, what if it is the Hall effect sensor? I'm not convinced that's the case, because it's definitely a phase problem. We can see it on the oscilloscope. All right, I did a little bit more reading, and I'm actually going to end the video here. I'm pretty confident that both of these chips are bad. It is weird that they're both bad in the same way, but I'm pretty positive that this board had failed exactly like I remember it, where this just didn't spin. It's all coming back to me now, having worked on this drive. So again, if anyone has any experience with these chips and failing phases, or these drives not spinning properly and you being able to fix them, is the problem somewhere else? Is it somehow one of the tantalum caps has gone bad? Again, I don't see that. They're not shorted, and that's the main point. They're all connected properly. So yeah, if anyone has any experience, definitely let me know. And I guess that's going to be it for this video. It was super unsatisfying to, I know, you and also me. But I got to get back to the Lisa, and I'm going to be doing that with the 800K drive. So I need to put this drive back together properly. Otherwise, I'll never remember how to do it. And it's kind of cool in a way that I have all those extra spare parts for the HP drive. I didn't realize there's motors and all sorts of different stuff in there, all the various parts. It did not have automated eject, so I don't have that. The main PCB is totally different because that drive was not a Macintosh drive. It was from an HP. But I do also have the read-write head assembly from that drive as well. So in case this head is bad, I theoretically have another, but I never knew that drive worked anyways, that's why I scrapped it. So yeah, anyways, there we go. If you liked this video, thumbs up. If you didn't, you know what to do. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye. And here's a little postscript for people who watched to the end of the video, the very end of the video. So after reading that thread and seeing that someone mentioned that the external drives for these early machines have the 400K drive in them, I went and I looked, and I happened to have 3 of those drives, and one was missing the drive cable. So I think someone had already pillaged parts from it. I opened it up, and inside the drive had a 400K mechanism. It was completely gummed up. So what I ended up doing is swapping the freshly lubricated top part off of the drive I was just working on onto the gummed up drive, put it all together, and it freaking works. It just freaking works. It boots the computer perfectly. Other than lubricating the jack screw, cleaning the heads, I did not recap it, and it just freaking works. So I'm going to put this Frankenstein drive into the Lisa, and I'm just going to go with this. It has a date code of September 1984 on it.